change in position? So distance indicates how far something is moved, but not which direction. And distance is measured using the meter, which is symbol M, kilometer, which is km, centimeters, which is cm, or millimeters, which is mm. And again, this all depends on like how far you're moving and the size of the object moving, etc. Now, displacement is the distance and direction of an object's change in position relative to a starting point. So from wherever you start, your displacement is the distance and direction from that starting point. So for example here, the distance traveled in this picture is 80 meters. This started here and traveled to the other end of the field, then turned around and came back 30 meters. So they went 50 meters this way, then turned around and came back 30 meters. So that's a total of 80 meters. So 50 plus 30. So that is the total distance traveled. However, the displacement is only 20 meters to the right. Why? Because you started here, you ended up here. So you ended up 20 meters from where you started. So even though the total distance traveled is 80 meters, the displacement is only 20 meters. So displacement is always either less than or equal to the total distance traveled. Okay, displacement cannot be greater than the total distance traveled. It's very common on like windy roads. If you think about West Virginia, you've got a bunch of windy roads. So you may follow a road and it goes something like this. Okay, that would be your total distance following that road. Your displacement would be from where you started directly to where you ended up. So that would be your displacement, and the direction, obviously. So you have to have the direction and the distance for the displacement. But the displacement is a straight line from where you started to where you ended. Doesn't matter how you got there. So adding displacements. So if displacements are in the same direction, you simply add them together. So in other words, if it's 5 meters east and then another 5 meters east, you just add those together and it's a total of 10 meters east. Okay, so 5 meters east plus 5 meters east is equal to 10 meters to the east. You show this with vectors. These are vectors. It's an arrow. Kind of the length of the arrow shows the magnitude, and then the direction of the arrow shows the direction of motion in this case. So you really take the tail of one arrow and connect it to the head of the other arrow, and that way you can kind of add these together. If displacements are in opposite directions, you subtract them. So if you go 10 meters to the east, you draw this long arrow pointing to the east, and then 5 meters to the west, you draw the shorter arrow coming back 5 meters to the west. Well, your total displacement is 10 meters east minus 5 meters west, so 5 meters to the east. And again, you can figure this out by taking your two vectors here and attaching the tail of one vector to the head of the other vector. So you start here, you go this way, and then you take this vector here and start it right there, come back here, and then basically from where you started to where you ended, that's your total vector, or your total displacement in this case. You cannot directly add displacements that are in two different directions. You need to break it into the x and y components and then combine them separately. That's one option. You could use some trigonometry here to figure this out. Or you'd use a very detailed drawing. So if you did a scale drawing, you could also figure this out without having to use any trig. But trigonometry basically refers to the relationship between the sides of a triangle and the angles in the triangle. But short answer is you cannot directly add displacements that are in two different directions.